Binary systems are used in the design of digital electronic systems because the base of a binary quantity is easily represented by an electronic device. For example, if we set a threshold like 3.3 volts, wherein if the voltage is less than this threshold, we call it logic 0. And greater than this threshold, we call it logic 1. We can consider this region as logic 1 and this region as logic 0. So if we can establish these kinds of region, then we can now send bits of information from one point of a circuit to another. Now, even if there's energy dissipation in the circuit, as long as the voltage do not overlap the threshold, then we can establish the fact that an electronic device is either in logic 0 state or logic 1 state. Logic 1 and logic 0 can be expressed in other ways like positive 5 volts and 0 volt, or on and off, or true or false, high or low. Now, a logic gate is a physical device that performs logical operation on one or more logic inputs and produces a single logic output. The internal structure of a logic gate consists of a sophisticated transistor circuit or other combination of diodes and transistor circuits that performs specific logic function. An inverter or NOT gate is a logic gate that performs an inversion or complementation. The standard logic symbol for NOT gate is a triangle with a bubble as a negation indicator. So let's represent the input as A and the output as X. If we were to write its truth table, its input is A and its output is X. And based on this definition, if A is 0, then its output is 1. And if the input is logic 1, then its output is logic 0. Again, if its input is logic 0, then its output is logic 1. And if its input is logic 1, then its output is logic 0. If A is an input variable and X is the output variable, then the operation of NOT circuit is represented by X equals NOT A. An AND gate is a logic gate that produces a logic 1 output only when all inputs are logic 1. An AND gate can have 2 or more inputs. This is the standard logic symbol for AND gate. Let's represent its inputs as A and B and its output as X. Let's write down its truth table. Its inputs are A and B, its output is X. So if both A and B are 0, based on this definition, the output will be 0. If A is logic 0 and B is logic 1, then again based on the above definition, the output is 0. Or if A is logic 1 and B is logic 0, then the output is still 0. But if both A and B are logic 1, then that's the only time it will produce a logic 1 output. So the operation of AND gate can be represented by this equation. X is equal to A times B. Or I can remove that dot. A times B. An OR gate is a logic gate that produces an output of logic 1 when any of the inputs is logic 1. An OR gate can have 2 or more inputs. This is the standard logic symbol for OR gate. Let's represent its input as A and B and its output as X. And let's write down its truth table. Its inputs are A and B. its output is X. So if both A and B are logic 0, based on the above definition, its output is 0. And if A is logic 0, while B is logic 1, since one of the inputs is 1, then based on the definition above, its output is 1. If A is logic 1 and B is logic 0, then again, its output will be logic 1. And finally, if both A and B are logic 1, then its output is logic 1. The operation of OR gate can be represented by X equals A or B. NAND gate or NOT AND gate is a logic gate that produces an output of logic 0 only when all inputs are logic 1. This is the standard logic symbol for NAND gate. Basically, it's an AND gate but with a bubble to signify complementation of the output. Let's represent its inputs as A and B and its output as X. NAND gate can have two or more inputs, and NAND gate is also known as a universal gate because AND, OR, and NOT gates can be implemented in terms of NAND gate. So let's write down its truth table. Its inputs are A and B, and its output is X. If both A and B are logic 0, then based on the definition above, this would be 1. And if A is logic 0 while B is logic 1, the output is still 1. If A is logic 1 and B is logic 0, the output is still 1. And when both A and B, or when both inputs are logic 1, then that's the only time the output would be logic 0. Now, the operation of NAND gate can be represented by the equation X is equal to A and B NOT. The NOR gate or the NOT OR gate is a logic gate that produces a logic 0 output when any of its inputs is logic 1. NOR gate can have two or more inputs, and the NOR gate, just like the NAND gate, is also a universal gate because the AND, OR, and NOT gates can be implemented in terms of NOR gate. This is the standard logic symbol for NOR gate. Basically, it's an OR gate with a bubble on the output. And let's represent its inputs as A and B, and its output as X. Let's write down its truth table. When both inputs are logic 0, based on the above definition, this is 1. If A is logic 0 while B is logic 1, then this time the output is logic 0. If A is logic 1 and B is logic 0, then the output is logic 0, again based on the definition above. And finally, when both inputs are logic 1, then the output is still logic 0. The operation of a NOR gate can be represented by the equation X is equal to A or B, then you complement the result. The XOR gate or exclusive OR gate is a logic gate that produces a logic 1 output only when the two inputs have different logic levels. This is the standard logic symbol for XOR gate. So let's represent its inputs as A and B and its output as X. Let's write down its truth table. So if A is logic 0 and B is logic 0, based on the above definition, the output will be 0. If A is logic 0 and B is logic 1, since the inputs have different logic levels, then the output will be logic 1. If A is logic 1 and B is logic 0, then again they have different logic levels, then this will result to a logic 1 output. And finally, if both inputs are logic 1, since they don't have different logic levels, then this will result to an output of logic 0. The operation of XOR gate can be represented by the equation X is equal to A XOR B. When constructing actual digital circuits, you cannot buy a single piece of logic gate. Rather, they are produced inside integrated circuit or IC packages like this one. And one IC package may contain several logic gates. Don't forget to like this video, subscribe to my YouTube channel, and hit the notification bell button for awesome updates. Thank you for watching!